This is the 24th DevGuild event. Show of hands for whom it's the first time to be at a DevGuild event.
Does Armageddon count?
No. This is alright. So 24th time over 3-4 years. This time also then sponsored by Fortumo in their lovely office with I haven't had any pizza, but I hope it's good. There's some people with Fortumo shirts and sweaters. Ask them for a tour later. Some announcements. Next event, roughly in a month or so, is going to be in Oxynon. Exact dates to be announced. Also, some friends from Riga who are organizing Riga's Dev Club and similar kind of meetup, and now a bigger DevOps 2-3 day conference, have provided us a promo code to get a 10% discount. It's happening next month, early in October. If you're interested, check out DevOps Unicorns and use the Tartu promo code. A bit about the agenda. We're going to have 2 talks, a short break in between, and some mingling later on. Pretty basic. And without further ado, Jaan from Fortumo will give first talk.
So thank you. Welcome to Fortumo office. And my name is Jaan Elken. And I'm a software engineer at Fortumo. I've been working as a software engineer for a little bit more than 5 years. And at Fortumo, just under a year. So for those who don't know what Fortumo does, we offer carrier billing. That is a way for users to pay for goods with their mobile phone bill. So we bring together merchants, users, and telcos. And the topic of my talk today is going to be A/B testing with AWS CloudFront, Lambda at Edge, and CloudFormation. It's going to be based on a project we undertook in Fortumo a few months ago. And since we use Amazon Web Services heavily, it's going to be quite AWS-centric. And roughly speaking, my talk is going to be divided into 3 parts. First, why we wanted to A/B test. Second, how we implemented it, considering our tech stack. And last, what are the takeaways, or what did we learn? And hopefully it's something we can use as well. Okay, so first, just to give you a bit of context, Fortumo has several products. One of these is called Direct Carrier Billing. It's essentially an API, so the merchant can integrate a web shop or mobile game or whatnot against the API, so they can offer carrier billing through that. But in addition to that, we also have a product called Hosted TCB. There we offer a web flow that we host ourselves. And all the merchant has to do is direct the user to the web flow, where the user completes a very simple payment flow, and then the user is directed back to the merchant. So here we host the web page. So this product is what we are going to be A/B testing, and it's been live a few years now. Of course, one of our main goals when improving the product is to maximize conversion. So we want as many users as possible that go to the site to complete the payment flow. And once you're past the obvious UX things and usability issues, well, I was just going to mention that what it actually means to us. So we want to get every last percentage of the conversion that is possible, because let's suppose we have 1 million page views and each successful payment generates $3, $3 as revenue. Then just improving 1% user conversion equals already $30,000 to the merchant. So we want to maximize the conversion as much as possible. Now the thing with the product is that our product is very much like a utility. The users spend very little time on the page. They very often don't even know what Fortumo is when they complete the flow. So selecting what features to improve conversion becomes a guessing game at some point, because it's very difficult to tell what the impact would be. So essentially we're like a water company. So as long as the water flows, you don't go to the company with the feature requests. Okay, so that's why we decided to do some A/B testing, since it would allow us to figure out what actually impacts the conversion. So what is A/B testing? Well, essentially you split your traffic into several parts. You create several versions of your application, you introduce some variants, and then you measure some criterion. And depending on the test result, you either keep the variation or not. For example, suppose we replaced the green button with the blue button, and then we measure the click rate. Wow, it's 60% instead of 40%, so we hit the blue button. This is just an example. So we decided to introduce A/B testing. Now, this is of course going to be dependent on our tech stack. So a few words about that. We deploy our web pages to S3 buckets. So S3 is Amazon's simple storage service. It's essentially something like Google Drive. It's just a space to keep files. But you can also convert buckets into public web pages. So we host our web page, which is a single page application written in JavaScript in S3 bucket. And of course, this application communicates with the backend services. In front of that bucket, we use a CDN. We use Amazon's CloudFront CDN service. This essentially is like a cache that is geographically close to the end user, so it decreases latency to the end user. Okay, and then users interact with the CDN nodes. And we use TeamCity to build and deploy our website to the S3 bucket, and we also use TeamCity to invalidate our CloudFront distribution. So invalidation just means that we tell that once we've deployed the new page, we just tell the cache that now the old files that are cached there are now invalid, and when a request hits the cache, it needs to go to the bucket again to retrieve the latest file. Okay, so again, this is how CDN works. The various locations are close to the user. There are points all around the world. And if the request hits the cache, it doesn't go to the origin. And it returns the response straight from that cache. And here are the locations of the cache locations. So as you can see, there are quite many of them. Okay, so that was the current situation. So where should we put the A/B switching logic? So where is the logic that splits the traffic? So one of the options is to put it inside the application itself. It's in some ways the easy option. So you just introduce some code that decides based on the characteristic or randomly which version the user should see. And then there's some if statement. If the user is in that group, show blue button. If not, show green button. But we didn't quite like that solution because it introduced this extra code into the web page. And this code you have to maintain, and if you end your A/B test, then you also have to modify your page again. You have to remove that. And so we wanted to do the switching instead on the infrastructure level. So in this case, we'll have two different pages, two different buckets. So in practice, these would be two branches of our application, two Git branches. And these are deployed separately. And then we do the decision or splitting traffic already somewhere before. In this case, it has to be before, it has to be in the CloudFront. Okay. So how should we go about doing this? One another consideration is that in this case we need to also take care of sticky sessions. It means that we shouldn't allow a situation where a user gets a mixed set of resources. So if you see the experimental version, you need to get all your files from that same bucket. Otherwise, things could break down. Okay, so luckily there is a way to put logic into CloudFront, and it's called, it's possible with something called Lambda at Edge. So before I go into that, just a few words about what Lambda is. Lambda is Amazon's version of, well, if you heard about what Google Cloud Function is or Azure Function, it's essentially a way to deploy code without managing any servers. So just deploy your function, define some triggers that execute it, and everything else is taken care of by Amazon. So it's very suitable for some tasks because you only pay for compute time consumed. So you only pay for the resources the Lambda actually consumes. And so if it's never executed, you don't pay anything. Yes, and scaling. So scaling is also managed by Amazon. So if you need 10,000 parallel instances, then Amazon will take care of it. So it's very useful for tasks that run only intermittently, for instance, once a month or once a day, so you don't want to provision a machine for it. There are some limitations, namely there is a time limit, so Lambda can only run for 5 minutes. After that it terminates. There is also code start delay, so if you run it first time, it takes some time to prepare the runtime. And it differs depending on the language you use. Okay. So in 2017, Amazon introduced something called Lambda at Edge. So what it is, it's a Lambda that runs from CDN edge location. So the Lambda is replicated into all these edge locations around the world, and it's run directly there. And it can be used to modify requests and responses that pass through the edge location. And Amazon themselves, they list some use cases. Some of these are not quite realistic, but really interesting. For instance, you can use edge lambdas to, for example, add a security header to all responses that pass through the CDN node. Or, for example, you can cut off all bot traffic. So if you identify the request as originating from Googlebot or something like that, then you can just terminate the request. You can do all sorts of things. One of the things they list is A/B testing. So we decided to investigate this further, and I found a very good blog post by Lorenzo Nicora, who outlined how to do this kind of A/B testing with edge lambdas, and our implementation quite closely followed the one outlined here. So, how should it work? First, I said that you can deploy it into edge locations. There are actually 4 different positions where you can execute the Lambda in CloudFront CDN. So this is now the edge location. So if there's an incoming request from the user's browser, and just before it hits the distribution cache, you can execute the viewer request. And this can modify the request in any way. And if the response is returned from the distribution cache, then the viewer response can be executed. And this can modify the response in any way. And when there is a cache miss, so the response isn't cached, it needs to go to the origin to ask for the file or whatnot. Origin request can be executed, and when the origin returns a response, then origin response can be executed. So 4 different types of Lambda edge functions. And a side note that these 2 will be always executed, since, and these will be executed only when there is a cache miss. So the response isn't cached already. Okay, so we are going to be using 3 of these lambdas. Just roughly speaking, what they're going to do, we're going to be using the cookie to ensure that the user always ends up in the same origin. And we're going to have 2 origins which correspond to the 2 buckets. We call those main and experimental. The job of the viewer request, in our case, is going to be setting the cookie X source, and it will select it randomly. So 50-50, either to main or experimental. And it's only going to set it when it's not already present in the request. Okay. So the job of the origin request lambda, in our case, is going to be rewriting the origin based on the X source cookie. So if it's main, it's going to direct us to the main S3 bucket. If it's experimental, then it's going to change the request and tell it to go to the experimental bucket instead. Then we have the third lambda, the origin response lambda, that modifies the origin response. And here we're going to set the header, set cookie. This header will tell the user's browser to set that cookie for all subsequent requests. So all of the subsequent requests will hit the same origin. And in addition, we need to modify our distribution configuration. We need to make sure that the X source cookie is part of the cache key. So we'll have all the files cached in 2 versions, one for both origins. So that seems quite complicated, so let's look at some use cases. So let's consider a user who has never visited our site, who makes a first request to the edge location. So since he has never been to the page before, the request doesn't have the cookie we're looking for. So the request hits the Lambda function. The Lambda function randomly determines which bucket it should go to. And in this case, let's say it rolls experimental. So we'll add this cookie to the request. Now, this response hasn't been cached, so the edge location needs to go to the origin, or the S3 bucket, to get the file. But before that, the origin request is executed, and this one rewrites the origin to the experimental bucket, so we get the file from experimental. And the response is returned. We'll set the cookie header, and the response is cached, and the set cookie header is also cached. And this gets returned to the user, and the user's browser sets the cookie. Okay, pretty simple. Now suppose the user loads the index.html. It refers to app.js. Now the browser wants to get the app.js file. The request already has the cookie, so the viewer request doesn't do anything. The cookie is still XOR's experimental. Origin request behaves exactly the same. Origin response behaves the same. And the file is cached, the response is cached, and everything is the same. And crucially, the user gets the file from the same bucket. So we have satisfied the sticky session requirement. So now suppose the user refreshes their page, so we'll load the index.html a second time. So the cookie is still present. The user hits the viewer request. Everything is still the same, but now we already have the response cached, so we don't go to the origin, we just return the response right away. Okay, so that's how it works. Okay, so the implementation of the three functions, as you can see, they're written in JavaScript. They run Node.js runtime. They are quite small, so just a few hundred bytes. So I'll show a very simplified version of how it works. So just is the viewer request function. If we have the source cookie, we select origin randomly and set it. Then we do the callback, which just means that we pass the request on. And here this is the second lambda that it determines which origin is going to be hit. So here we read the cookie. If it's experimental, then change the origin and then just continue. And this is the one that sets the set cookie header. Okay, so this should all work now. So the question is how should we get it deployed? How should we make it actually work? Well, we could use AWS Console, which is the point-and-click interface, essentially. So you could do it all with your mouse and keyboard, but the problem is that we'd have to do it again for different stages, if you have different stages. And you can't reuse the same setup in different projects, or you can, but you have to do it manually again. And instead, we will use CloudFormation. So CloudFormation is a service Amazon has. It essentially allows you to define your infrastructure as code. So you write JSON documents that describe what resources you want to have provisioned. You upload them to AWS, and it creates the resources for you. And the advantages are that the templates are reusable, the JSON templates, and they can also be reviewed by peers, so you can show them to others or have second pair of eyes. So I'm going to just skim over the templates that are created. So first we need our 2 buckets. So we just create an identical bucket to the first one. And as you can see, they are made publicly available. The index document is an XHTML. So these are going to be hosting our single-page applications. Then we need to modify our distribution. So here you can see that we have 2 origins now. And by default, we'll be targeting main. And also important here is that we are making the, you can see here, we're making the X-source cookie part of the cache key. So we need to whitelist it, otherwise it will not be considered when creating cache keys. Okay, so now we need to create roles for Lambda. So if anybody wants to execute the Lambda function, it needs to assume this role. And this is pretty much standard, but we also need to add H Lambda as a principal here, because H Lambda also needs to be able to execute our function. Then we'll define or create a template for our Lambda function. Here I'd like to point out that it pays to add a default body to your function that is just a pass-through function that basically does nothing. But if you leave it empty, then you accidentally, like if you deploy this and attach it to your distribution, then it will immediately kill your distribution because it doesn't, basically the request stops there because the function doesn't do anything. And this is quite dangerous because if you if you first upload your Lambda and attach it to a distribution, then it will be replicated to all the cache, all the CDN locations, and it takes quite some time, and you can't modify your distribution while you're doing it, so you can just look while your site is dying. So that's quite inconvenient, so I recommend adding this here. Okay, now we have the lambdas and the roles. Then we also we use Team City as our continuous delivery tool, and we want to allow Team City to deploy our websites and also deploy our Lambda functions for us. So for that we need to first create a policy that allows all these actions that Team City needs to undertake in order to do this. So first of all, it needs to need some rights to manage the Lambda functions. For instance, enable an application for it. Here we can specify, it's collapsed here, but here we can specify exactly what function we will allow this policy to apply to. So it's quite specific. This is something that's needed for when you first create a Lambda at the edge function. Then you need to allow creating a service link role. But this is just needed once, but doesn't hurt to add it here. Then we need to allow Team City to update their distribution. And unfortunately, you can't be more specific here. You need to allow it for all resources at the moment, because it's a limitation of CloudFormation. Otherwise, I would just put our distribution ID here, our specific distribution. Okay, and then we just add a role that the Team City agent or Team City account can assume. Okay. So much for cloud formation. Now we also want TeamCity to actually build and deploy our code. So for the websites, we'll have two configurations that are identical, but just deployed to different buckets. So first of all, we'll have npm to build our website, and then there's a bash script that uses AWS CLI to assume the role which has created, upload the distribution contents to S3, and validate the distribution cache. And as you can see, we have two different deploy jobs after that. And then we also want to have build jobs for deploying Lambda at the edge functions. So once again, we'll use npm to build our Lambda code. And well, Lambda at the edge has one limitation. It cannot use, or it has several limitations, but one of these is that it cannot use environment variables, which kind of makes sense because function is replicated on the nodes and want to be consistent. So it needs to know exactly what function version it is replicating. So we can't use environment variables. And once again, there's a quite complex bash script that assumes the deploy role. It uploads the Lambda function, publishes it, extracts the version ID from the response. And as I mentioned, we can't use we have to know the version ID because we can't use the latest alias. So latest alias is something that can be used with ordinary lambdas. It basically means that always pick the latest published ID, but with Lambda dash you cannot do. Then we download the distribution configuration, attach Lambda with that ID to the configuration, and update the distribution again. So I created a bash script, but I would not do it again. I think I would use Python, because Python has a quite good AWS library, and also it's pretty good at manipulating JSON. It's horrible to do it with a shell script. Okay, so as a result of that, we'll have deploy functions for our Lambda edge functions as well. And you may ask that why do we actually why do we even need it? Because probably you aren't going to change them very much or very often. They just need to be put in place and then they work. Well, actually, you can. There is a use case for deploying it more often. Namely, you can include into the build process of the viewer request, for instance, the ratios you want the traffic to be using. So whether you want to be split 50-50 or use like 20-80 or whatnot. So this needs to be all done during build time because no environment variables. Okay, so if we could just add a TeamCity parameter and change it here and just press run and it would work. Okay, so now we deploy everything. We go to our website and it's a 50-50 whether we land on the experiment version in the experimental bucket or in the main bucket. So in this case, we landed here. So it works. There are some limitations to this approach. As I mentioned, no environment variables. Also, if you do caching validation, then it is path-based, so it will drop all versions of an object. So we'll have, even though we have two versions, and the cache keys are different because one of them has the main cookie, the other experimental, but the validation drops all versions. Also, you have to be prepared that the operations you do with CloudFront take an undeterminate amount of time. So because everything is replicated, and Amazon usually doesn't allow you to, for instance, delete a Lambda until all references to it are also deleted. So, for example, if you want to delete the replicated Lambda, it takes lots of time because it needs to do it in all these locations. And how much time? Well, Amazon doesn't say. It just says that it's indeterminate. And in practice, I've seen it take like half an hour. Unfortunately, you don't need to do that very often, probably. Okay. Detaching a Lambda, in my experience, seemed to be faster. And also, with this setup, you will obviously have two branches. You will have the A branch or the main branch and the experimental branch. It means that if you develop some other feature that is not being A/B tested, then you need to merge it to both of those branches. So you essentially have two production branches, which is a bit of a bother, but not that bad, I think. And there are some setups that allow you to do automatic merges and stuff like that. So in that case, it won't be an issue at all. Okay, and the big bonus, I think, to this approach is that you can do gradual rollout for web pages that are behind CDN. So usually, the way we had it before was that, of course, you can do testing and staging, but when you put it in production and all the users hit your web page, then it was possible that something came up that, some weird browser or whatever that you just couldn't foresee. And this offers an additional safety net, because you can, for example, put your changes into the master branch, deploy it to main, so 50% of users, for example, will see your changes. Then you can monitor. We also have client-side monitoring, so we get JavaScript errors also that clients have. And if there are no issues, then you can release to main as well. So it's like an additional safety net that doesn't kill your traffic completely. So in my opinion, it's worth it for doing this for this alone, even if you're not doing any A/B testing. Okay, so what is the cost of doing this? So I looked at the numbers in August. Monthly cost for CDN and S3 hosting was around $58, and with Lambda at Edge it was $57. So it's $7, and I counted 8 million executions of the Lambda at Edge function. So it's a lot of computation, but not very expensive. Okay, so what's the performance cost? Well, generally, since we're using Node.js runtime, it's quite fast. So here you can see all these dots are the spikes, or like occasional longer load times. These are about 50 or a bit more milliseconds, and most of these occur in regions where there is like almost no traffic. It means that the lambdas are cold and their cold starts. But there are regions where there's lots of traffic, like for example, I looked at Singapore separately, and there the maximum run time was 1.2 milliseconds. So it's quite fast. So on average, it's like 1 millisecond. It doesn't slow your site down considerably. So what did we actually A/B test with it? So our first feature was this logo here, secure payment. So we read somewhere on the internet that if you add it to your website, then it will improve conversion because users will trust you more because of the logo. So we ran it for a few weeks, and the initial results were a bit confusing. We found that the experimental had slightly worse total payments than the main. So okay, what logo actually made things worse? What does it mean? But when we split the traffic across different merchants, then we found out that one of the merchants that most of the, or all of the, the difference was caused basically by one merchant, and that merchant had 97% returning user. And when we looked even closer, it appeared that there were really heavy users on that that merchant. So probably some sort of reseller or whatever that used our flow to buy thousands of things. So it really skewed the results. So we just eliminated that user from the results. And by the way, we used Google Analytics for this analysis. Then we found that there was basically no difference between the page version that had this and the page version that didn't. Okay. Yeah, and we used this page to do the computation for measure for calculating the statistical significance. So you need to have a big enough sample size for the results to be significant. And if you're not a mathematician, then there are tools on the internet that you can use. Okay, so what are the key takeaways from this? So our first result was a negative. The change didn't improve anything, but in my mind it was still a good result because the no code is the best code since you don't have to maintain it. And also most of our users are using our page from a mobile phone, and with the screen real estate is really important, and if you can keep the clutter off, then it's really good. Also, it's good to know your customers. So it really helped us out that we could to look. We knew that how that merchant uses our product, or you could just use something called ATP testing. So it's essentially similar, but instead of having split traffic into two, you split it 4 ways. Show 2 of the groups, the A version, and 2 of the groups B version. And then you can just compare if A's are equal and B's are equal, then any difference between A and B should be significant because it's just a way to avoid noise. It should be quite easy to implement this setup as well. You just need 2 more cookie values. Okay. That's something I already. Yes, and just be aware that if you're. It should be cloud. It's CloudFront, yes. So changing CloudFront take indeterminate amount of time. It needs to sync with all the page locations. So if you make any, be sure that you don't make any mistakes because you need to wait a while before you can correct them. Okay, and also it pays to take the time and invest in using CloudFormation because infrastructure as code has lots of advantages over just doing it manually. Okay, so that's about it. Thank you for listening. Questions?
Yeah. How much time did it take to collect all the required data?
To collect what?
All the required data.
For what exactly?
For the A/B testing and comparison of A and B groups, for the statisticals.
Okay, we just I don't know, a few hours from Google Analytics because it already measures all the. We have all the data already there, so it wasn't Yes.
My question would be not regarding the AWS, but rather about the Team CTO. So it's self-hosted CI, as much as I know. It's a self-hosted CI, right? So that you set up this on your own server, or it's a cloud CI.
I think we use our own hosted.
Own hosted. Why would you do that? Why would you? Because there are so many cloud services. So what is the benefit of self-hosted for your company?
I don't really know the answer for that. So I guess we want to set up our own agents the way we like it. So according to our own needs, our build agents. And we don't want to wait for the features we need are implementations.
Okay.
We want to have control. Any more questions?
Have you had any other interesting results from any A/B tests or surprising results?
Actually, it's the first. Well, we have only tested one feature to the end. Now we're running the second one. So this is the only result I can tell you right now. Okay, so I guess that's it.